Assalamualaikum warahmatullahi wabarakatuh. Welcome to our presentation MAT5C5 Advanced Differential Equations. So for our assignment is Fourier series and harmonic analysis. In this group assignment, we have 3 members, which is FARZANA ASFA, HAZIRAH Adam, and myself, MAWARKHAIZUL. Before we start with the question, we must know and understand what is Fourier series and the harmonic analysis. Okay, first, for the Fourier series, an expansion of a periodic function fx in terms of an infinite sum of sines and cosine. Fourier series also makes use of the orthogonality relationships of the sines and cosine functions. And for the harmonic analysis, a branch of mathematics concerned with investigating the connections between a function and its representations in frequency.
So for task 1, I will explain about equation 1, which is about an even function. What is an even function? So for a function to have an even Fourier series, it must satisfy the condition f negative x is equal to fx for all x in the interval of interest. Or in easy way, we can say a function is called even function if f negative f is equal to fx. The function I use for even function is cos x over 3. The limit for this function is x from negative pi to pi. Firstly, you need to sketch the graph, and that's how the graph look like. To get the fx, the next step we need to calculate the a0. Then after we get the a0, the next step we need is to calculate the an. And after we get the an, the last step is by using the formula a0 over 2 plus sigma an cos n pi x over l. We substitute all that we have calculated before into the formula to get the fx. Secondly is about an odd function. What is an odd function? So the function must satisfy the condition f negative x equal to negative fx for all x in the interval of interest. Or in other words, a function is called odd function if f negative x is equal to negative fx. For the example, for odd function, I was used the fx is equal to sin x. For odd function, a0 and an must equal to 0. Same with even function before, must sketch the graph first. The graph sin x was look like that with interval in negative pi to positive pi. To find the function, which is fx, by using the formula, we need to calculate the b1 first. After that, we can substitute into the formula to get the fx. And then lastly, about the question 3 is about neither function. What is the neither function? How to tell if a function is even, odd, or neither? A function fx in which fx is not equal to f negative x and negative x fx not equal to f negative x for any value of x is neither an even function nor an odd function. Graphically, these functions are neither symmetrically about origin nor about the y-axis. How to answer this question? Like always, we need to sketch the graph first by referring the interval to get the fx. We must calculate the a0 and an first. After we get the value, we can substitute into the formula, but this method was quite long because we need to use a tabular method to find the an. So from there, we can get the fx after we calculate the a0 and an. That's all from me.
The next questions for the task 2 that we'll discuss in this presentation. The question required to sketch graph of fx on the interval negative 6 to x to 6 and give the expansion series. Consider the functions fx is equals to x the power of 2. First and foremost, I will explain about the solutions the cosine series in this task 2. This is show that the functions of the fx is an even function because of the graph is symmetry about the y-axis. Okay, for these functions, we need to calculate the value of a0 and an, and then we need to substitute the value of l, which is equal to 2, and the value of function is to be x squared. Since the limits was from 0 to 2, insert to the given formula and we get the final answer as the following. Next is for the odd functions, we need to calculate by using the sine series, and the graph will show that it is symmetry about the origin, which is to the x-axis. This is an example of the calculations for the odd function. We need to calculate the value of bn and then substitute the value of l, which is equal to the 2, and the function is to be the x squared. Once we get the bn, we need to insert to the sine series formula function. Last but not least, this is the graph of the Fourier series function, which is neither even nor odd. It is show that it not symmetry about the y-axis or the origin. The solution calculations is for the Fourier series neither even nor odd function. We need to substitute the L equals to 1 and the function is to be x squared and to find the A0, AN and BN. After we got the A0, AN and BN value, we can get the final answer by using the formula for the series function.
Now, let's take a look at task 3, where we need to solve a harmonic analysis question. So the question asks us to find the Fourier series expansion up to the third harmonic, and all the calculation must be in a correct 3 decimal places. To solve this question, firstly, we need to find the summation for the y cos x and y sin x. Since the question asks to find up until the third harmonic, so we also need to find the summation for y cos and y sin for 2x and 3x. Since I'm using Excel to solve this calculation, bear in mind that the x value need to be changed from the degree to a gradient since Excel uses radian for its trigo function. From this, we can find the value of A0 where it is 1/6 times with the summation of y, and C0 where it is 1/2 times with A0. For step 3, we can find the AN value with the formula of 1/6 times with the summation of y cos and x. Next is to find BN. It is like finding the AN value, but for BN, we substitute the summation of y cos and x to y sin and x. Now we can calculate the value of Cn by using the formula of square root of AN square plus BN square. Move on to the next step, which is to find the angle value. For this, we need to inverse the tangent of AN over BN, and only then we can find the angle by referring to the formula of the quadrant. Lastly, after we manage to obtain all the values, now we can substitute the value into the Fourier series form, and now this is our final answer. That's all from us. Thank you for watching and have a nice day.